This tutorial is all about plate solving. If you've been using a go-to mount like this for some time and you're looking to take the next step towards precision, alignment and framing of your astrophotography shots, then plate solving is a really important part of that. In this video I'll be explaining exactly what plate solving actually is, describing the benefits of it and what it can actually do for you, then explaining the hardware that you need and the different types of software that are available for doing plate solving, and telling you which of those I think is the best to use. I'll show you how to install the software and set it up within your astrophotography software. In my case I'll be using the example of Sequence Generator Pro for that. And then I'll show you what I do in a typical session to plate solve and sync to replace my star alignment and get a much easier way of getting accurate pointing in the sky. And then I'll plan an image using a framing and mosaic wizard that will very accurately define the image I want to take, and then use plate solving to frame my shot very precisely against the plan. So let's get started. So what is plate solving? Plate solving is the process of analysing any image you've taken of the night sky against a database of all the brighter stars in the night sky to try and find a match, so that that match can then give you the position of your image on the celestial sphere in terms of right ascension and declination, and also in terms of the rotation of your image compared with the database of the sky. So just by way of example, I've got an image here that I've taken of the Elephant's Trunk Nebula, and because I've done some practice for this, I actually know that if I resize this to 31% in terms of size and then rotate it by 95 degrees, that I can then overlay it on this reference image of the Elephant's Trunk Nebula, and you can see there the stars line up really beautifully. So in plate solving, the computer is looking for this match in the pattern between your image and the database. Now there are two types of plate solving that the computers can perform. The first, if you like, is a sort of standard plate solve, is where you don't just provide the image, but you also provide an approximate location in the night sky, so the computer knows where to start searching, and also you provide the scale of your image, typically in arc seconds per pixel, and that also helps the computer to find that match. The other type of plate solving is called blind solving, and in that instance you just provide the image. You don't give any information about where in the sky you think it's of, or any information about scale, and that clearly is a much bigger task for the computer and can take a very powerful computer a number of minutes to solve, whereas the standard plate solve can be complete in a remarkably short period of time, typically 1 or 2 seconds, and that's where the real power of plate solving comes in. So what I'm going to do next is just explain why plate solving is so useful. So the first thing, which we've already covered, is that plate solving can tell you where you're pointing, the right ascension and declination, and what rotational orientation. Now knowing that information is then potentially a substitute for what you do when you star align. So if you're used to star aligning by slewing to a chosen bright star and then trying to adjust your pointing to try and get that bright star in your field of view of your camera, then getting it in the center and then pressing a button to complete the star align, you're creating a sync point, which is an extra point in a database inside your mount that enables it to point more accurately in the night sky with your current setup. Now if you plate solve, you don't need to use a bright star, you don't need to try to fight to get that star to be inside your field of view. You just slew to somewhere, take a picture and plate solve, and the plate solve determines where you're pointing and creates the sync point for you if you command it to. There's a thing in Sequence Generator Pro called solve and sync, so it does the plate solve and then creates a sync point using the result of the plate solve, and that is a brilliant substitute for star alignment, in particular when you have longer focal lengths. So if you're dreaming of having a much longer focal length, as I am at the moment, one of the problems you'll have is getting an alignment star actually in your field of view so you can do your star alignment. But with plate solving, the problems goes away because you can take a picture of, albeit a narrower part of the sky, and plate solve it to find out where you're pointing and create the sync point that way. Once you've created your sync point, you can then slew to a bright target, which is often done for focusing, and put your Batonov mask on, for example, to focus, and your bright star will be right in the middle of your field of view almost straight away, because you've already plate solved in a portion of the sky that's somewhere nearby. So it's really powerful in that respect. Now the next thing that it gives you is, well, if you no longer need to try and fight to get your telescope pointing at a bright star and getting it in the field of view, then if you've got a Telrad or a red dot finder or a finder scope that you have on your setup for that purpose, not for guiding but for getting a bright star in the field of view of the camera, you can remove it. You don't need it anymore because the plate solving is sorting that for you. So you're taking weight off of your kit, and that hopefully will bring you a bit of improvement on your guiding. So that's a nice advantage as well. And the next thing is that it now becomes much more realistic or practical to actually carefully plan your imaging. The framing of your shot can be chosen from the database. You can decide exactly where you want to position the image, what rotation you want, and save that as a plan. And there's a framing and mosaic wizard, as I mentioned before, in Sequence Generator Pro that does this, and I'm sure there's other software as well. That is then your reference plan, and you can then use that to slew your mount to the location, and then takes a picture, plate solves it, and then it can see what's the offset in right ascension and declination and the offset in rotation, so you can make adjustments in the pointing of the mount, and if necessary apply a rotation either manually or using a rotator to get that shot framed exactly as you planned it. So that's a really nice thing to be able to do. Now that capability then makes it really practical to come back on multiple occasions, maybe on successive nights, maybe even successive years, and come back to a target that you imaged a long time ago or yesterday or last week, and use the same planned reference target framing and get really close to the same framing that you had before, so that when you come to stack all of your data from this session and the previous ones, then you've got minimal wastage around the edges because of misaligning the framing of your data. So that's really great. And then the next logical step beyond that is that it now becomes practical to form data sets that are a mosaic. Now I'm actually currently working on a 3x3 frame, so it's a 9-frame mosaic of the Elephant's Trunk Nebula, and that I would never dream of attempting without plate solving. But I've got such accurate control now of my framing for each shot that I can go back with confidence and acquire data on each of the 9 segments of my mosaic on different nights, and it's going to take me probably 3 years to finish that image because of the great British weather, but I have the power to do that because of plate solving. So these are all the benefits that plate solving gives you, and I don't think it's an exaggeration to say that once you master plate solving, you will never look back. I don't do any sessions where I don't use plate solving now. I use it for my sync before I find a bright star to do my focusing. I use it to frame my shots, and I use it for framing mosaics of shots as well. So that's what plate solving can do for you. So what equipment do you need to be able to do plate solving? Firstly, you're going to need a telescope and camera that's mounted on a go-to mount, and you're going to need that go-to mount to be set up for remote control from a computer. In my case, I use a Skywatcher HEQ5 mount, and I use the ASCOM platform and the EQ mod to make the connections between the computer and the mount. Secondly, you need image acquisition software such as Sequence Generator Pro, which is the program that I use. There are others like Astrophotography tool, Nina, etc., which I have much less experience of. But you need software which can integrate with your camera your mount and with the plate solving software, which is the other thing that you need. So you probably find you've already got the top two bullets here, and you just need to get yourself the plate solver software. So now I'm going to go through the available plate solving programs and just give you a little outline of them, and whether they cost or whether they're free, and what my experience of them is. So I've created a list of all the plate solvers that I know about, and there may be others, and I've grouped them as seeded solvers and blind solvers. The seeded ones being the ones that you give an initial position for the search to start at, and you give it the scale of your imagery. So the first is Plate Solve 2. Now this is the one that I used the most when I first started plate solving. Works fine, but I did get a little frustrated that after it found the match, it would then sit there for a number of seconds before it returned control back to, in my case, Sequence Generator Pro, and that was wasting time in my session, and I couldn't find a way of turning that off, so I ended up changing from that one. I've never actually used Pinpoint because you have to spend $149 to get a license for it, so I've no experience with that one. Acedap is the one that I changed to when I got frustrated with Plate Solve 2, and Acedap really is really super. It's fast, it's seamless, it's integrated within Sequence Generator Pro, although it has its own standalone GUI that you see here. But as soon as it finishes and has the solution, it gives the result and control straight back to Sequence Generator Pro, and you don't waste any time. There are then the blind solvers, and probably the most well-known one of those is an online solver called Astrometry.net, and that uses a very powerful computer. It's on a server, it's sitting there waiting for requests. You have to upload a request from your computer to their site. It schedules it in and performs the task, and then you get the solution back, and typically it might take 1 to 2 minutes to come up with a solution, depending on how busy it is, how good your image is, and how long it takes, obviously, to find that solution. So that's astrometry.net. There are a number of others which perform blind solve but use a local database, and so they're performing the search on your own computer. They are NSVR, Astrophotography, and AllSky Plate Solver. I don't have any experience with those, so I'm not going to sit and pretend that I'm an expert on those. But for me, the go-to plate solver to use is Acedap. I've had no problems with it whatsoever and really love it. It just works brilliantly. But it's important to be able to have a fallback if Acedap fails to find the solution and you're miles off and you don't know what to do. Having a blind solver available to you can be useful. On Sequence Generator Pro they call it a failover or fail-safe or fallback. There's lots of names for it. They call it the failover, but essentially it's a fallback solution. If Acedap doesn't find a solution for some reason, then you could try astrometry.net. So that's my go-to, if you like, fallback blind solver solution. Okay, so let's install Acedap. So go to Google, type Acedap, and select the hnsky.org website. There's various installers here for different operating systems. I use Windows 64-bit. You can obviously choose the one that's appropriate for you. You need to install both the application using Acedap installer and also the database. Now the database is at revision H at the moment. I use the 17 magnitude database because it's a bit smaller and that works fine. If you want to install the larger database that goes to 18 magnitude, you can do. So I'm going to click on Acedap installer. Takes you to the SourceForge website. You have to wait a few seconds and then the install starts at the bottom, and just click open and we'll run that. Next, install, and automatically close anything that's open. And we won't launch it when it finishes installing, and click finish. Okay, so now we'll go back to install the H17 star database. Again, it's downloaded through SourceForge. We'll allow that. So it's 481 megabytes, so it does take a little bit of time. So I'll click open when done, and I'll come back in a minute when that's finished downloading. Okay, so that's just finishing downloading now. Okay, just take the default scenarios there, and now the H17 database is installing. Okay, that's done, and we just click finish, and that's all there is to installing it. So the next thing to do is to set things up in Sequence Generator Pro. So here we are in Sequence Generator Pro, and there's just a few simple steps we need to follow to set it up to use Acedap. So the first thing is to go into Tools, Equipment Profile Manager, and select the profile that you want to use plate solving with, and then go to the Camera tab, and where you've got pixels down the bottom, my camera is 4656 by 3520, so I'm going to put those numbers in there. And then the pixel scale is very important for the plate solving. It needs to be in arc seconds per pixel. Now if you're not sure what the value is for your setup, you can go to my website at martinsastrophotography.com and click on the Calculator Tools button, and then scroll to the bottom of the page, and there's an image scale calculator there where you type in your sensor width in millimeters and in pixels, your telescope focal length, and if you're using a reducer, you put the reducer factor in, otherwise just leave it at 1, and it will tell you your image scale. So for me it's 0.9801. that's with a ZWO ASI 1600 mm Pro and an 800mm Newtonian. So come back into here, and in image scale I will put 0.9801 and then hit save. So that's saved into my profile. The other thing I need to do is go to the Plate Solve tab and choose the appropriate interface. So we're going to change that to Acedap, and we're going to set up the search. I always use max regions, so it can go as far as it can to try and find a fix. It goes out from a spiral from the seed point, and I use 2x2 binning. It's up to you what binning you want to use, but 2x2 downloads a bit quicker, which is nice, and we'll have a better signal to noise ratio as well. And I normally use something like 8 seconds. You can tell it what filter you want it to use if you wanted to use a specific filter for plate solving, but it's not really terribly important. There might be certain circumstances, perhaps when there's a lot of moonlight, where you might want to use your hydrogen alpha filter, for example. Otherwise you can just leave it to use whichever filter is currently selected. The blind solve failover, if you tick that and it fails to get a solution with Acedap, then you can click on settings here and you can choose to use, for example, astrometry.net, and the ANSVR local version is also available should you prefer to use that if you don't have any internet. So you can then tell it how many times it can try to center the camera on the scene that you're trying to get to, and so I normally set that pretty high. Normally only takes 2 or 3 goes, but I set it to 10, and essentially that's the number of times it will plate solve, work out how far off it is, tell the mount to shift, ask you to rotate the camera if needs be as well, then do another plate solve, and then go again and again and again. And of course each time, once it's done the plate solve, it works out how far off it is, both in pixels horizontally and vertically, and also in degrees rotationally. And so that's what these two numbers are, the 50 pixels and the 3 degrees. Those are the limits that I've chosen to use for what I call an acceptable centering of the image on what was planned. So once you've set up all those values, you hit save, and that's essentially all of your setup is complete. And now all that's left is to show you how to use it in anger. So I'm all set up with my Skywatch HEQ5. This time I've got 400mm lens with a monochrome camera and filter wheel. I've got a 9x50 guide scope with a monochrome guide camera, and I've done all my cabling and I've done my balancing. I'll just wait for it to get dark enough, I'll do my polar alignment, then put the mount in the home position. So we'll start by creating a new sequence using the relevant profile. I don't want to save the old sequence, and choosing the profile, the equipment profile for the equipment that I have set up. I'll create a new sequence with that, and I will connect to the camera, connect to the filter wheel, connect to my focuser, and connect to the mount. Now if I bring in the EQ mod window, we can look under alignment points and see that we currently have no alignment points, which is because we've done no star alignment and no plate solving and syncing. So if I look in Stellarium, I've already connected to the mount in Stellarium, and in fact I'm just going to
slewing to target,
slew back to Polaris because I've already moved it elsewhere. So after I switch the mount on and connect to the mount, it's pointing roughly here. So at that point I would choose typically a bright star close to what I want to image. Now I want to image the North American Nebula, which is here tonight, and the nearest bright star that's visible at the moment is Vega. So I'll select Vega, click current object and slew.
slewing to target,
So the mount is slewing to Vega.
slew complete,
So the mount now thinks it's pointing precisely at Vega. So if we go into Sequence Generator Pro, I'll just close the sequence window and we'll switch to 1x1 binning on the frame and focus, and I'll take, let's say a 3-second shot. I'll set my filter to luminance, moving the filter to luminance, and now I'm going to take one 3-second shot and we'll see if we've got Vega in the shot. Okay, so there's our picture, and you can see that Vega is not in the shot. So what I'll do, I'm going to bring up the control panel, and tonight I'm going to turn off this use filter HA so that I can stick with the filter that I've selected. And I'm just going to change my error margin to 50 pixels, so 10 attempts, 50 pixels, 1 degree error. That's fine. So now I'm on luminance, so let's just take, let's say, an 8-second shot on the luminance filter, just to get a nice signal to noise ratio. It's still a little light, the sky, so I just want to make sure I've got a decent number of stars in there for the plate solve. Now if I just do the simplest form of plate solve, all it does is to analyse the photo and see where it is in the sky. So let's show you that first. I'm going to right click on the image and click plate solve. Solve. And it solved it. So it says successfully solved the current frame, and this is where it's telling us the image actually is, but we haven't actually created a sync point by doing that. So what I'm going to do this time is bring up the control window and do solve and sync. So this time it will do actually be a 2x2 binned 8-second exposure on the currently selected filter. So let's click on that. So it's now acquiring an 8-second shot on the luminance filter. It's downloading the image.
sync,
Now it's plate solving it. and it says the telescope has been synchronized. So that's the extra bit. It's done the plate solve again as it did before, but now it's also done a synchronization. And if I bring up EQ mod and we go in and have a look at the alignment sync list, you can see that it now has this one entry, which is the entry for Vega. So it now has, if you like, the equivalent of a 1-star align. So we'll just minimize that and OK this. So if I go now into Stellarium and we zoom in, you'll see that it actually knows where the telescope is pointing now. You notice it's not on Vega anymore, it's moved over to here. So if I select Vega now, click current object,
slewing to target,
it will now repoint the telescope,
slew complete,
to point it at Vega. And we can prove that that's been successful by coming back in and doing another frame and focus shot. So we'll do another 1x1 8-second shot on the luminance filter, and this time we should see Vega hopefully right in the middle of our shot. And there we go. So the plate solve has effectively replaced the star alignment process for a 1-star align effectively, and I could just as easily pick other stars. I could go back into Stellarium, I could pick other stars, and I could plate solve on those as well, or do a solve and sync on those. For example, Deneb, which is even closer to the object I'm going to be imaging tonight. Click current object and
slewing to target.
So now we're slewing to Deneb.
Slew complete.
And with the slew complete, I can bring up the control panel again and do another solve and sync. So it's acquiring a new 8-second shot. Downloading it.
Sync.
And there you go, it's plate solved and created another sync point. So here's the image it produced. This is Deneb. You see it's not quite central, and if we look in EQ mod we can see that we now have 2 alignment points, one for Vega, one for Deneb. Okay, and just for completeness, if we wanted to put Deneb right in the middle, we can bring up Stellarium in the same way, and we can select Deneb, current object,
slewing to slew complete.
And now if I take one shot, we should find that Deneb is right bang in the middle. There we go. So this is really convenient now for doing focusing. So I'm just going to put my batten-off mask on and set my focus, and then we'll do a frame and focus wizard and actually plan an image and then use plate solving to acquire it. So I'll be back in a moment. So I've done my focusing. Now I want to take an image of the North America and Pelican Nebula, and I want to plan that image. So I'm going to bring up Tools, Framing and Mosaic Wizard. Now the North America and Pelican Nebulae are in an object defined as NGC 7000, and you can define a field of view as how much sky you want to fetch. So if I only fetch say 2 degrees, it'll fetch quicker, but I'll get less sky fetched. So let's fetch 2 degrees of sky, and there we go, and this is the North American Nebula. Now I can't quite see the Pelican Nebula because it's over here a bit, so what I'm going to do is increase my 2 degrees to 5 degrees and fetch again. It'll take a bit longer now because it's fetching a larger portion of its database. There we go. So it knows about my sensor size and my image scale because I used the equipment profile. So what I'm going to do now is just drag a single rectangle onto the image, and then I can click and drag the center of that and move it around. Now when we get into more complex things like mosaics, you can actually start to do 2 by 1, 2 by 2, etc. by changing these numbers down here. But for now I'm just going to do a 1 by 1 image, and I can slide this rotate selection and rotate the image until I get an orientation that I'm happy with. So I can drag and I can rotate and I can get exactly the piece of sky that I'm after and decide exactly how I want to frame it on my sensor. So let's say that that's what I want to achieve. So I'm happy with that. I'm going to click Create Sequence. And it now offers me the opportunity to either append targets to the sequence. Well, this sequence got nothing else in it, so I'm just going to replace any targets in the sequence, so it's just got one target entry. And here I can choose when a target starts whether I want to slew to and center on a location, or just slew to it but not do the centering. The centering uses plate solving to get the pointing exactly right, whereas the slewing just moves the mount to where it thinks it needs to point. But I am going to leave this rotate or validate camera angle ticked, and that's important because I don't just want to get the right pointing, I want the right rotation angle as well. And I'm going to leave this associate working image with sequence ticked so that this image, this planning image you see here, remains visible, so I can go back and refer to it later. So I'll click OK, and it says success, created one new target, and it brings up the sequence window, and you can see it's now created one target called NGC 7000. Now there's one thing I also need to connect which I didn't connect before, and there's a little slim arrow here, and there's a rotator called manual rotator. I don't have an electronic rotator, so I just rotate the camera by hand, and to do that you need to use manual rotator so that you get the right interaction with the software. So I'm going to connect my manual rotator, which sounds a bit strange, but that's what you have to do. Okay, so far so good. So we've planned this image. Now what we want to do is actually slew to that location and use plate solving to get the pointing and the orientation exactly right. So to do that, I'm going to right click on the target, and I'm going to do center target and rotate camera. So let's select that.
Slewing to target.
So the first thing it's doing is slewing to the target, as it says. So you can see that it's moving to the target. Once it's done that, it will
Slew complete.
It's completed that, so now it will take a shot. So it's capturing an 8-second shot. We happen to be on the HA filter now, but that's fine. It downloads the shot. There it is. Now it's plate solving it,
Sync.
which it's managed to do, and so it's concluded that this first attempt failed. It's out by 36 pixels in right ascension, 14 pixels in declination, so actually both of these are within the 50 limit that I set, but there is a rotation error of 156.4 degrees. So I now need to go outside and rotate my camera clockwise by 156.4 degrees. Now I won't be able to do that perfectly, but I'll go and have a stab at it, and then it will you'll see what happens. It'll then go through the process again and see how close I am. So I'm just going to go outside. I'll be back in just a moment. So what I actually did was to attempt to move it anti-clockwise by the difference between 156.4 and 180, which is about 24 degrees. The software will allow you to be orientated in rotation 180 degrees out, because of course you can just rotate the picture 180 to get what you want. So click OK. It's capturing a new frame. And it's plate solving it.
Sync.
Okay, so I did quite a good job there, and it says success. We are now within 0.9 degrees, which is just inside my 1 degree rotational margin that I allowed. So we're done, and we should have a shot that is very close to being what we planned. So let's test that. Let's do a 20-second shot, We'll do it on HA because this is a strong hydrogen region, and I will take one shot, 20 seconds, one by one bin. I think I can actually just about see the Cygnus wall part of this scene just there, but we should get a much better view on this 20-second shot, which is downloading now. Okay, the sky's still a little bright, but you can certainly see the Cygnus wall there. Now if we compare the planned shot, well, let's just zoom this in so that we're just looking at the image we planned, almost full screen there. And there's the Cygnus wall. You can see these two stars and these two stars just for comparison. And we go back to our frame and focus shot, and there are those two stars and those two stars. So we've now got ourselves oriented in terms of pointing and rotation to point exactly at the place that we planned to point to. So that's the power of plate solving, to enable you to do your star alignment and also to very accurately plan and implement imaging of a precisely framed shot. Hope you found that useful. Clear skies.